Have you ever looked at a tiny Lego brick and thought, how the heck do they make billions of these without messing up the fit? Well, buckle in, because today we're going deep inside how the Lego story comes about and into the Lego factory to see how plastic turns into magic. While you're watching, drop a comment below. What's your all-time favorite Lego set? I'll share mine later in the video. The Lego story begins in 1932 when a Danish carpenter named Ole Kirk Christensen started making wooden ducks and yo-yos in a small workshop during the Great Depression. Business was rough, so Ole made toys to survive. Fast forward to 1947, Lego becomes one of the first companies in Denmark to buy an injection molding machine. And in 1958, something revolutionary happens. They patent the design of the modern Lego brick. It's got these hollow tubes inside, which give the bricks just enough grip to hold tight, but still pull apart easily. Here's the crazy part. Bricks made in 1958 still fit perfectly with the ones today. That's not nostalgia, it's engineering precision. Everything starts with a material called ABS, acrylonitrile butadiene styrene. Think of it as the super plastic. It's impact-resistant, lightweight, and holds shape for decades. Why ABS? Because Lego bricks need to click just right and survive being tossed, stepped on, and even chewed. Yeah, we know what toddlers do. Now here's where it gets wild. Lego doesn't just melt random batches. They mix precise color formulas using pigment blends developed over decades. Their labs track over 200 specialized shades, including niche colors like bright bluish green and earth orange. These aren't just cosmetic. Color consistency is essential when building large sets. Ever tried building a Millennium Falcon and half your gray bricks look purple? Nightmare. Here's a fun fact. Lego has a full-color library team just to manage shade accuracy across factories globally. Even a 1% hue difference can get a batch rejected. Once colored, the ABS plastic gets funneled into high-pressure injection molding machines. These are the mechanical heart of Lego's production lines. The plastic gets heated to a whopping 232 degrees Celsius, then pushed into precision-engineered steel molds at speeds of up to 150 kilometers per hour. And these molds, they're works of art. Each one can cost between $50,000 to $100,000, and Lego has over 2,400 active molds running globally. What's crazier? A single mold might contain multiple cavities, for instance, 8 brick slots that all get filled at once, and they're accurate down to 0.002 millimeters. Molds get swapped out like NASCAR tires. Some only last for 3 to 5 million cycles before they wear down, meaning Lego needs to constantly calibrate and replace them. Each year, Lego's machines produce over 100 billion parts. That's more than 12 times the number of people on Earth. Here's where things get obsessive. Lego has automated vision systems, basically robot eyes, that inspect every single brick. They're trained to spot issues down to the tiniest imperfection, a micro scratch, a discoloration, even a warping so small the human eye can't see it. If the machine flags it, that brick gets sucked away and reground back into raw material. Rejected bricks never leave the factory, but that's just the first checkpoint. Every batch gets randomly sampled by real humans. These guys measure clutch power, that iconic snap sound and feel when 2 bricks connect. Too loose? Rejected. Too tight? Rejected. Lego even has custom-built machines that repeatedly press and release bricks to mimic years of kid play. They simulate aging in real time. Lego calls its tolerances the sacred standard. Their internal metric? If 99.998% of bricks don't meet the fit test, the whole batch is trashed. Minifigures aren't born blank. They go through a separate, high-tech process using UV digital printers. These printers apply ultra-fine layers of ink to Lego heads and torsos, working at speeds of 1,000 prints per hour. Each pass lays a new layer: skin tone, facial expression, outfit details, and accessory outlines. Some prints need multiple machines to complete. For example, a Harry Potter minifigure might go through 4 to 5 different print phases, each with unique alignment. Designing a character isn't just drawing a face. Lego has a whole team dedicated to this. They study how expressions read on such small surfaces. Eyes too wide? He looks scared. Mouth too low? Now he looks bored. Here's another fun fact. The most expensive Lego minifig, a solid gold Boba Fett figure, worth over $11,000. Once all the parts are printed and passed inspection, they go through a mind-blowing sorting process. High-speed weight sensors and shape detectors separate pieces into bags. Each Lego set is then packed with instructions, stickers, and codes that tell you which bag to open first. The biggest sets can have 6,000 plus pieces and come in dozens of numbered bags, like a meal kit, but for engineers. Lego is on a mission to go green. The company has committed to making all core products from sustainable materials by 2032. In recent years, they've begun manufacturing select elements using recycled PET plastic sourced from discarded bottles. Each prototype brick undergoes stress tests, color matching, and long-term durability analysis. So far, over 250 different elements have been successfully replicated using sustainable materials. It doesn't stop at bricks. Lego has redesigned packaging too, switching from plastic bags to recyclable paper pouches inside boxes. And all defective bricks, they're collected, shredded, and melted down to be reused in new production runs. A closed-loop system that reduces waste. Lego has invested over $400 million into sustainability research and development initiatives. Now here's what makes Lego the GOAT of toys: compatibility. Every single brick produced since 1958 still fits with the ones made today. That's because Lego engineers maintain a tolerance of just 5 microns. That's less than the width of a human red blood cell. This compatibility isn't just convenience, it's a design philosophy. Lego calls it the system. Every piece, whether it's a castle turret, spaceship engine, or tiny frog, is part of one interconnected world. They also archive every mold ever made, thousands of steel blocks preserved in climate-controlled vaults. Why? So a discontinued part can be revived for future projects or collector's sets. Imagine this. Where else can a 1970s pirate sword snap perfectly into a 2025 Iron Man mech suit? The modularity and backward compatibility are why adult fans of Lego, AFOLs, can still use their childhood bricks to build masterpieces decades later. So now you know, from a pile of ABS plastic pellets to a perfectly molded, quality-checked, play-tested icon of creativity. Oh, and remember that question from earlier? My favorite Lego set is the Saturn V rocket, 1969 pieces, of course. If you learned something today, give that like button a gentle snap, just like a good Lego brick. And subscribe to see more mind-blowing factory secrets. Drop a comment. What's the weirdest thing you've ever built with Lego?